Hello learners, Mr. G here, and in this video we're going to be practicing work, energy, and power. The topic, power, is not going to be part of this question though. This question was question 5 from November 2017. And let's try to do it as fast as we can. The question says, in the diagram below, a 4 kilogram block lying on a rough horizontal surface is connected to a 6 kilogram block. So let's quickly have mark here the data. We have a 4 kilogram block, 6 kilogram block, rough surface. Rough surface means that a frictional force is different than zero. It's not zero in that specific part. Now it is connected to a 6 kilogram block by a light inextensible string passing over a light frictionless pulley. Initially the blocks are held at rest. Now held at rest means that the initial velocity of both blocks is equal to 0. Okay, so here is the drawing. That is the picture. You have the 6 kilogram block lying down and they are at rest. Okay, eventually you will read later on, eventually the blocks will move. Okay, but not now. Now state the work energy theorem in words, and let's just answer that one quickly. Now the work energy theorem in words. Now the work energy theorem states that the net work done on an object is equal to the change in kinetic energy. That is the work energy theorem, and if you do that correct, you get 2 marks. Let's go to question 5.2 very quick. They say, when the blocks are released, the 6 kilogram block falls through a vertical distance of 1,5 meters. So it falls 1,5 meters. If we go to the drawing, that is the displacement. So the displacement is going to be equal to 1,6 meters. And remember, both of them are going to displace 1,6 meters. What you need to know as well is that this object is moving in that direction, and this object is moving in this direction. Moving down, moving to the right. Okay, that is important to know here. Now, if we keep reading, they say draw a label free body diagram for the 6 kilogram block. Now, for this block here, what forces are acting for the 6 kilogram blocks? There is the gravitational force or weight, and there is the tension. So let's do quickly the free body diagram for the 6 kilogram block. So what we have there, we have gravitational force down. I'm going to write Fg. And we have the tension pointing up. Tension pointing up. This one is 2 marks. 1 for the gravitational force, 1 for the tension, and you will have 2 marks. Okay? We carry on. 5.3. Calculate the work done by the gravitational force on the 6 kilogram block. Now, all the data is in the picture. We are not going to rewrite the data here. I don't want to take too long because the question is quite long. So I'm going to show you 2 options, 2 ways of doing this one real quick. The first one, they ask you to calculate, both of them, they ask you to calculate the work done by the gravitational force, and that will be equal to gravitational force multiplied by displacement multiplied by the cosine of theta. Theta is the angle between the force and the displacement. Or we can say that the work done by the conservative forces, which is the work done by the gravitational force, is equal to minus change in potential energy. So these are the 2 options that we can do this question. If we carry on here, we have that the work done by the gravitational force is equal to mass multiplied by acceleration due to gravity multiplied by the displacement multiplied by the cosine of theta. And here, this is O. The work done by the gravitational force is equal to minus bracket mass multiplied by acceleration due to gravity multiplied by final height minus mass multiplied by acceleration due to gravity multiplied by initial height. It's either one. You don't have to do both. Now here we are already prepared to substitute. We have the work done by the gravitational force is equal to the mass is 6 kilogram. You're working with a 6 kilogram block, 9,8 multiplied by the displacement, which is 1,6 multiplied by cosine of theta, and theta is 0 degree. The object is moving down, and the gravitational force is also down. So the angle between the gravitational force and the displacement is going to be 0. Okay, so the work done by the gravitational force using this method will be 94, sorry, let me just erase this one here real quick, 94,08 joules. That is the answer for the question using this method. If you use the other method, then if you do the substitution work done by the gravitational force, it's equal to minus the mass is 6 multiplied by 9,8 multiplied by the final height is going to be 0. Okay, minus the mass is 6 multiplied by 9,8 multiplied by 1,6. 6. This is a 6 here. Okay, and then the final answer will be equal to 94,08 joules. So you can use either way, and you will get the same answer. By looking at the free body diagram, you know that the work done by the normal force is equal to 0, as well as the work done by the gravitational force in the 4 kilogram ball is equal to 0 as well. So the only forces we have here that does work for the whole system is the work done by the gravitational force on the 6 kilogram block and the work done by the frictional force on the 4 kilogram block. So those are the only forces that actually do work. So let's write here the substitution of those formulas. Work done, you can calculate the separated if you wish. Work done by the gravitational force, this is for the 6, is equal to gravitational force multiplied by displacement multiplied by cos of theta. But remember, you did calculate that one already. So this one was calculated, and the answer is going to be the one calculated in the previous question, 94,08. 94,08 joules. That one is given. That one is this one here. Now, the work done by frictional force, this one here, work done by frictional force is equal to frictional force multiplied by displacement multiplied by cosine of 180 degree. Okay? Now, the small issue here is that we don't have frictional force. So we have to go back to the formula of frictional force. And this is not a big problem. Frictional force is equal to kinetic coefficient of friction multiplied by normal. And the normal force, in this case, if you look at the free body diagram, the normal force will be equal to the gravitational force there. So here we have that one there. So frictional force is equal to kinetic coefficient of friction multiplied by the gravitational force, which is equal to kinetic coefficient of friction multiplied by mass acceleration due to gravity. And then if you substitute here, you have that this one is a 0,4 multiplied by 4 multiplied by 9,8 multiplied by cosine of 180 degree. So the frictional force is going to be equal to 15,68 Newton. And this one must go there, so we can calculate the work done by frictional force. So here we substitute now 15, this cos of 180 is extra here. That is for the gravitational for the work done by the frictional force. So here we are by 15,68 multiplied by the displacement, which is 1,6 multiplied by the cosine of 180. Now we are right, and this is equal to negative 25,088 joules. Now we have the work done by the gravitational force of the 6 kilogram block, and we have the work done by the frictional force on the 4 kilogram block. So now we can calculate the net work. Okay, so we are here. We can now do the whole substitution. We have 94,08 plus minus 25,088 is equal to half mass, we're going to do the mass of both of them, which is 10 multiplied by the final speed. We are looking for that one. We're looking for the final speed square minus half multiplied by 10 multiplied by 0, which is the initial speed square. Okay, it's 10 here because the objects are moving together. It's a system, so that's why I use 10 there. I add the masses and we get in the final speed of both of them, which is the same one. Okay, so if we do the calculations here, we have that this is 68,992 equal to half multiplied by 10 multiplied by final speed square. So if you solve this one, which is quite easy, the final speed is going to be equal to 3,71 meters per second. This is the answer for the work. Okay, now this question have a lot of marks, and the marks allocation are going to be, let's see, the total marks is going to be 5 marks. The marks allocation are for the work energy theorem, which is that one there, one for the calculation of the work done by the frictional force, which is this one here, this substitution here, that calculation there. This one is already calculated previously, so obviously you are not going to get mark for this one in this question, just for the substitution there. So one for the calculation of substitution of the net work, which is this one here, and one for the substitution there, and one for the final answer. So 3, 4, and 5 marks. Those are the 5 marks, and that is the first option. The second option is to use the law of conservation of energy. Now, for this option, you can start by saying that the work done by the non-conservative forces is equal to the change in kinetic energy plus the change in potential energy. Change in potential energy. So that is the starting point. And now remember, the only non-conservative force that is acting here is the frictional force, and frictional force is only acting on the 4 kilogram block. So this one will be here, in other words, will be the work done by frictional force is equal to half mass final speed square of object 1. Remember, this is for object 1 and object 2. So in this case, we can use here both objects at once, minus half mass initial speed square plus changing a potential energy. Now remember, the only object that change potential energy is object of 6 kilogram, because the first one, the height doesn't change. So the first object here, the first object of 4 kilogram, doesn't change potential energy because it stays along the same line. The height doesn't change. Okay, so this one won't have change in potential energy. So when we use the change in potential energy, it's going to be only for the 6 kilogram block. So this is mass multiplied by acceleration due to gravity, final height, minus mass acceleration due to gravity, initial height. And this is only for the 6 kilogram block. So let's this that one clear. This is for 6 kg. This one is for both objects. Okay, so that is important. This is for 4 kg. Why? Because it's the only one that experiences frictional force. This one is for both because both of them change the speed of the object. And this one is only for the 6 kilogram block because it's the only one that the height changes. Okay, so if we have this one, then we can do the substitution. And note the following: the work done by frictional force here, this one here, is equal to frictional force displacement cos of 180 degrees. You have to calculate it, but we did here calculate it already there. So I am not going to redo the calculation. You can come back here and see how do we calculate the work done by the frictional force on the 4 kilogram block. Okay, you can go there quickly and look at that one. So the answer for that one is going to be negative 25,088. Negative 25,088. Okay, so we are going to substitute here. There we go. And then if you do the substitution on the other side, you get the following: equal to half. The mass, remember, is for both, is a 10 multiplied by final speed square. You're looking for that one, minus half. Mass is 10 multiplied by 0 square. Okay, plus, and here we have mass. Let's substitute everything. This one is only for the 6. 6 times 9,8 multiplied by the final height, which is 0, minus, and then we have here 6 multiplied by 9,8 multiplied by, let's just fix this one here, so it does fit. So I will write it and then I'll be back. Here we are. So this one here is 0, this one here is 0, and this one here is 0. So what do we have here at the end? We have minus 25,088 is equal to half multiplied by 10 multiplied by final speed square minus 6 times 9,8 times 1,6. Okay, you can finish the calculation yourself, and then the final speed will be equal to 3,71. 3,71, like in the first option. I hope it helped. I don't want to make the videos too long, and this one is already going for 20 minutes. Okay, so there's the two options. I recommend the learners to practice both. Practice both because sometimes you don't know which one they're going to ask you in the exam. Sometimes they ask you for a specific option. So this, once more, is question 5, November 2017. It's a good question. It's a difficult question, I think. So thanks for watching. If you think it helped, thumb up, and good luck up until next time.